Good morning, everybody, and good afternoon, everybody, depending on where you are. My name is Fabrizio, and I work as in the developing team of EthoVision XT at Noldus, and welcome to this seminar about JavaScript in EthoVision XT. The aim of this webinar is to explore new ways to look at and analyze track data in EthoVision XT. Just say what is this webinar is not about. This is not intended to be a webinar about JavaScript itself. I'm not a programmer and I'm a novice of JavaScript coding. So if you do not know JavaScript or programming in general, it's just fine. My goal here, I hope, is to give you a sense of what additional information you can extract with the help of a few lines of code. On the other hand, learning JavaScript is easy. There are plenty of courses online. And if you need some help with making scripts specific for your research questions, consider that Noldus offers consultancy. And so please contact us to discuss your research needs so we can create scripts if necessary for you. So before I start actually the webinar, I would like to show actually the how JavaScript works in EthoVision XT, and I will switch to the screen. I will share the desktop. Okay. So I will switch first to EthoVision XT for a moment. And here we have a little mouse in a sort of open field. And what you see here is an integrated visualization of the coordinates X and Y of this mouse. This is the coordinates of the center point, right? I obtained this with a few lines of code in JavaScript. How did I do that? So if you look in the analysis profile, we have some new elements here at the bottom, JavaScript. And I just showed for now what it looks like in EthoVision XT. So you don't need an extra editor to enter code to process your data. The editor is in this dialog that pops up every time you call these JavaScript variables. So what I have here, just for now, just please look at this piece of code. We have now this get center command that is like telling EthoVision, give me the coordinates of the center point of the subject. And this will be stored in a variable called, for instance, PTC. And here you have the two functions, the two formulas that extract the X and Y coordinates of the center point. So with these few lines of code, you can extract features from the raw data. And once you get these features, process them or simply output them like I'm doing here with this code. I set these values to output. And this is what I get in my plot. As you can see, this dialog has the standard trial statistics and group statistics. And here I simply select the statistics that I want. For instance, the mean, the minimum, and the maximum. So they are just treated as any other statistics in any other dependent variable of EthoVision, something that you can see here in the results. So for instance, this is the mean of the x-coordinate of the mouse. So this is a very, very simple example that I hope it gives you an idea what JavaScript will do. So the result, yeah, again, these are the coordinates. Look at the green line here. This is the x-coordinate of the mouse, and you can see when the animal is, the standard calibration, the origin of the calibration, the scale is just in the middle of the image. So whenever the mouse walks on the other side, the x-coordinate will get negative values. Okay, I hope you are convinced that these two are the coordinates of this mouse, the center point. So let's go to the actual webinar. And before we start with the examples, let me give you a few, talk about a few key concepts here. During this webinar, we'll talk about the sample, okay? And when you look at your data in EthoVision, you tend to imagine that the sample is just the body point of a subject. Like in this case, we have the center of the body of this rodent. The same for if you track a small insect, you are interested in tracking the center point. But there's more. In a novel object, for instance, you track 3 body points: the nose, the center, and the tail base. So the sample is not just a point. You can view a sample like a box, like a container, which contains a number of features, depending on your setup. The same for a fish. For instance, you track a fish, you want to track the nose, the snout, the center, and the tail base. If you have a social interaction text, then you have 2 animals, for instance. So that means that the sample itself contains 2 sets of coordinates of body points. So it's crucial when you make your JavaScript code to know exactly which feature you are going to extract from the raw data. There is more. Because together with the coordinates of the body points, you have extra information. You have, for instance, the body area, simply the yellow blob that you see when you track the subjects, okay? Or the elongation, which tells you something about the shape of the animal. So this is a number of features that are called raw data, and they are just contained in this box that is the sample. And every sample time you can use this data, like I'm going to show in the next slide. Well, just imagine this is your trial, and this is the starting point. So when you click the Start Trial button, and this is your stop time. So when you click the stop time trial button, or at the end of the video, or when the trial control procedure tells you that the trial is stopped. We have a number of samples here, from 1 to whatever. So each of these can be seen as a sample. So your task is to make some code that opens up this box, which is the sample, and extract the features that you are interested in. Make some calculation. All this is done in what we call the process. So this word will come back often in this webinar. After calculations, you have to send these values to the output of EthoVision. So EthoVision will treat them as the value of any other variables like velocity or distance moved. So we see here the output for sample 1. We call it just O1. Well, it's not true that it's just one value. It could be different values, and we see later how we can do that. The same will be done for sample 2, 3, and so on. What happens if one of these samples is missing? Well, in the JavaScript code, you have to make sure that there must be some condition that if for instance, the body point is missing for some reason, then the output will be missing as well. So there's a way to instruct EthoVision, if you don't find the body points or whatever, then the output will be set to missing. So after that, how we do install this magic in EthoVision? You don't need any extra editor. You can use this for EthoVision XT 14 and 15, so the latest versions. It's free. And so all you have to do is to get this registration file that we also made it available on the chat in this webinar. It's a zip file that contains, and it contains a few folders with some examples. And then it contains these two reg files. Simply use the one that applies to your EthoVision version, either 14 or 15. Then reopen EthoVision XT, and then it's done. So it's ready to receive the code that you type in. And so I'm going to show here. Yeah. So this is the reg file that simply adds a registry key on your computer. Okay. It's ready. So what you will see in EthoVision in the analysis profile is a number of three extra items called JavaScript under this obscure name debug. Just please ignore the others that you see here. And well, that's not all, because this is about analyzing data. What you also see in the experiment is additional JavaScript items in the trial control settings and in the data profile, which means that you can use JavaScript code to trigger an event, for instance, in the trial control settings, to stop the trial or start a routine or whatever. So you can also use, I anticipate we'll have a look at the sample as an example here at the end of the webinar. So how you can use JavaScript code to control the process of your trial, not just to analyze existing data. So yeah, so what types of variables are we going to look at? Well, there are three types. You see here the name, continuous, state, and event. So most of you probably are familiar with these charts. This is the typical chart of velocity or distance moved, which means that you can define a JavaScript value just continuous. So at each sample, you see a value of the JavaScript, a numerical value. You can define a state variable, which is made of discrete components. Like an example is mobility or in-zone. Probably you're familiar with that. And the event is just a point in time that marks whatever event is important during the trial. So now we just skip the data acquisition here because there's nothing special that I could talk about, because I simply assume that we have the data already. So we have track data with clean coordinates, no missing sample, or a small number of missing samples, no misdetection. So good data, just ready for the next Nature paper. So we go to the examples, and let's see. I selected 4 examples here, and the reason is that first reason, I don't want to create overlap between different applications, okay? So for instance, I have one example here about fish and one example here about mice. But the real reason is that within each of these examples, I will point at a specific function or command that is probably quite often used when you work with JavaScript. Okay, I don't think I need to add anything else, and we can just get started and jump into it. The first example is the subject features. How do I get, for instance, the body length using the features of EthoVision XT? So here we have two examples. Consider a rodent in an open field and a fish here, two fish. We want to know the length of the body for whatever reason. We want to measure the extent of stretch behavior. Or in the case of this fish, you see that one is larger than the other. So it could be that I can use the length of this fish as a marker. Even though these two animals are not marked, I can individually mark them because I simply know the one is longer than the other one. So how do I get this body length from JavaScript? And I'm going to switch to, again, to EthoVision, and I will open the JavaScript code. As you can see, I made an analysis profile called body length, and it contains just one of these variables. And it's a continuous variable. So every sample, I get one value of body length. So let's take a quick look about what it is. And you can see that there is a function called process. That's quite important because this is actually the loop in which EthoVision looks at the features in the sample and then extract the data. And you have here the basic functions get nose, get center, and get tail, which obviously mean get me the coordinates of the nose, the center of gravity, the center point, and the tail is, respectively. So once I know the coordinates, once EthoVision knows that, I can calculate the length of the segment between the nose and tail, and between the center and tail, just the length I'm doing here. So this segment and this segment. So back again to EthoVision. What I'm doing is calculating the distance from the nose and the center point, and using the distance function. But where is this distance function? Well, I define it here above. This is the distance that is called every time I need to calculate a distance between two data points. This is basically the Pythagoras theorem in two lines of code. The JavaScript extracts the x and y coordinates of the 2 points, and then it returns the square root of the two squares summed up. So this distance function is called many times, and it returns the length of the segment. The two segments will be added up here. This is the symbol for updating the length variable with the new distance from the center point to the tail base. So now length is the total, the sum of the length of the two segments. Here I have an extra check. If one of the two body points is not existing, is missing, for whatever reason, I just skip this phase. So the points, the value of distance, the value of body length will be missing. I'll show you later what it means. So it's also good to add some code in JavaScript and that the checks that all data are valid. And this is the symbol of being valid, so not null. In that case, if the length is valid, I will set it to output. Otherwise, I will set it to missing. What does it mean? When I look at the visualization of this variable, this is my length of the body of the mouse in millimeters. I can see that when the animal is contracted, length is smaller, and when it's running or proceeding, then it's longer. You can see some variation here. You can remove this random variation by simply using the track smoothing capability. You know, when you go back to visualization, it's a smoother line. So I intentionally removed one of these data points, and let's see, when I do not use the smoothing, I can see one of the missing data points. I think here it is. Yeah. Why this value is missing? Because here I removed intentionally the nose point. So for whatever reason, when the animal is not and one of the body points will not be found, and so the JavaScript is just saying this is a missing sample. I know nothing about that, so I will not show any data. And as I said before, once you get the code in JavaScript, you're ready to run your statistics, and these are the values that you get. Also, you can export the raw data, and these will be shown per sample. I'm just showing an example here for body length. This is in an Excel file that I just exported from body length of this mouse. You can see there's an extra column, continuous body length, and then I have the length of the mouse for each sample. So whatever you define in JavaScript, it's just treated like any other variable in EthoVision XT, like you see here, or in other cases, velocity, distance, here elongation, direction, etc. Right. I'm going to close this. And let's see. Let's go back to the examples. I'm going to show you another example, and it's the velocity beans. Velocity bean is meant to not to find, extract a feature about coordinate, but it's just transforming data that are existing, like velocity. So I'm going to look at this example in which I have some velocity values plotted against time, and I want to code them, transform them in a kind of frequency distribution by using some thresholds. Again, what I'm gonna do is to open another analysis profile for the velocity beans, in which I have a state variable instead. So we have not just one, but multiple values per sample. And that's why you see here at the end, number of outputs is 4. That's because I have 4 categories depending on the thresholds that I set here at the beginning. You find all these examples in your zip file. Okay, you don't need to copy anything. So depending on the velocity that is calculated, again, according to distance moved and divided by time, JavaScript will assign a category to a specific sample, like bin 1, bin 2, bin 3, bin 4. So what it does in the process is to first calculate velocity by using the distance function, and of course the time. You need to get the time. How do you get the time here? Well, there's another function called getSampleTime. Again, it's predefined in EthoVision. You don't need to invent it. Okay. So this will give you the velocity, and then the velocity will be compared to various thresholds that you define at the beginning here in the code. These are in millimeters per second. Just an example. The result is that instead of 1 value per sample, you get 4. And indeed, it is what you see in the chart here. 4 different states. These are called 0, 1, 2, 3. And these represent the velocity in 4 categories. Again, you can calculate statistics like the time that the animal was in the 4th bin or versus the first bin, and so on. And this is the original data of velocity. Okay, so you can see when the velocity increases, then you have higher states being activated. And all these transitions, you can remove them using some filter in the code. I didn't do that, but I think it's possible to make a smoother categories here by using some filter that reduce the number of random transitions based on this value of velocity. Right, get back to these examples, and then we go to examples. Yes. So now we go to another set of experiments, because we are talking about multiple subjects. So I'm going to change the experiments, and I'm going to address these questions. When you have a Petri dish like that, how many mosquitoes are going to land at? Looks like it's a very trivial question. Come on, it's too simple, you know? And well, EthoVision cannot do that. You don't know how to calculate the number of animals that are in this arena or in a zone. And just like in this case, in a shoaling test or whatever, looks like a shoaling test. I want to know the number of animals that are present in specific zones. It's so shoaling test to measure the density of shoal. Again, EthoVision doesn't know how many animals are in a specific zone. It has to be done indirectly by using, for instance, the in-zone parameter. But I want to do, yeah, you know, more direct measurements. And again, in this example with Drosophilas, how many animals are going to be moving to the left side of this T-maze, and how many in the right side? We are going to use this example. Again, I'm going to open this experiment in EthoVision. And we have a new video with the Drosophilas, and which was kindly provided by Yazid Rashad, Georg August University, Göttingen in Germany. So we are going to look at this video. Yeah, it will take some time to load the data, because all these charts are made for each subject, and it's a lot of subjects in this video. We have actually 4 arenas, horizontal arenas. These are indicated with these 2 colors. The 2 colors are the zones. So the arena is basically those 2 zones together. The animals are released in the middle, and how many animals are going to be in this zone 1 at the left or zone 2 at the right? You can see if you play the video, well, there's no match. The zone 1 here is preferred. So there's a high number of animals that are running around here in these areas. And this is replicated 4 times, because this is a 4 arena experiment. So how do you count this subject? Is it so difficult? Well, with JavaScript you can, although it looks like, yeah, it's a basic, very basic question. Yeah, up to now it was not possible in EthoVision. And I'm gonna open the subject example, which is based on a function called isInZone. Basically, what you do is, once you define your zones in EthoVision, you give this name, for instance, Z1, you state, this is my zone, Z1, and this is my list of subjects, up to 15, or how many you're going to track in this experiment. And then you use this function as a marker. Every time a specific subject is counted, is found, you add up the counter here. For each sample, we get a value of this n counter. And you can see in this loop, what the EthoVision does, it gets the subject coordinates for a specific subject here. This is the index of an array that contains all the names of the subjects. And then it does simply a check. Is this subject in a specific zone or not? And if it is, then the counter is incremented. It's quite simple. If you want to know the number of the animals in the arena, you simply have to make a zone as large as the arena. And you don't need to specify which arena you want to use, because this is done automatically for each arena. So back again to our charts. Here we have the two plots for arena. Here we have example for arena 1, subject 1. You can see the plots are made for each subject, which is a bit redundant. So when you export the data, you can also make it a bit simple by simply selecting in the table just to remove, basically you select only one subject here, and you get the mean number of animals for each zone, for each of these arenas. So you can see here, arena 1, 2, 3, 4. And it simply tells you the mean. Of course, you can add more statistics, like simply clicking properties here and get, for instance, the minimum, the maximum, and other statistics. So this will be shown each zone. You can see here the contrast. Zone 1 against zone 2. For instance, here it's 5 versus 0, 6 versus 0, etc. So this was the subject counter. And yeah, the last example is a bit more complicated, and it's about the individual behavior. So what actually the animal is doing. Now we have an example of a fish, and this fish is tracked with the 3 points, so we know what the tail and the center point are doing. So what I'm going to do, I'm going to show you this thing. When the animal is just turning and beating the tail, you can see the path made by the tail is longer than the one made by the center point. So the purple line here is what the tail does, and the red line is what the center does. Now, is the way that I can use this data, this difference, so to kind of detect tail movements, like for instance in a mirror test with the zebrafish. Well, I'm not claiming that this is a super accurate, but at least to measure the amount of time that the animal is busy with beating the tail and moving near a mirror, for instance. We are going to show this again in the previous experiment using the second trial with the fish. And I'm going to show trial 2. And I select trial 2. And then I choose. What I'm going to show you is the tail beat detector, which has a number of variables. Okay, first I'll start from the final results. So I'm going to first plot the distance moved by fish. Okay, these are the original data from EthoVision, just for reference. So whenever you see a peak in the chart for distance, the tail base makes a longer path than the center point. You can see here. Yeah. So we could use this difference, this ratio perhaps, and I'm gonna show here, this is the ratio of distance between a distance moved by the tail versus the center. Okay, this is just a numerical variable, continuous. And I can use it to some threshold, some heuristic rule. I can detect when the animal is moving the tail. So whenever this value of ratio is higher than a specific threshold, okay, besides some filtering, some calibration, also depends on the size of the fish versus the arena, etc. I think you can estimate to a good level of accuracy the amount of movement that this animal is doing. I'm just showing you just for reference, what I did in JavaScript. This is the standard variable. So this is not JavaScript. It's just a distance moved, just because I wanted to show the distance moved in the charts. What I'm going to show you the JavaScript state. Again, this is a state. So basically, the output is yes or no, depending on the value of this ratio. Here it looks a bit more complicated. It looks like it calculates some ratio. I added here the log of the ratio of distance to center. I use log just to make the distribution a bit more normal, let's say, to remove some outliers or to reduce the importance of these outliers. But the important thing is that once you calculate this ratio, again, using simple functions like the distance moved, this one, which is a bit recurrent here, and compared with the threshold that you, have a kind of device, and then it will output a state, which is either true or false. And again, this is the code that tells you, that tell EthoVision, give me the state if the value of the state is valid, so the points are not missing. Otherwise, set an output as missing. I understand this was a bit quick, but if you have questions on this kind of parameter, let us know. Okay, the examples. I think I have one more list of. This is basically a list of the functions, not exhaustive, but I think these are the main functions that you use in JavaScript. We could go through each of them, but time is a bit running here. Basically, we talked about this function, most of them, like the get center, get nose, and get tail, and get subject center. These are used for different subjects. So when you want to calculate an event relative to a different subject, so you can specify a certain subject during an interaction, let's say. And get area is something like you do when you measure mobility of the animals. And elongation is, get elongation is basically what the EthoVision collects during the tracking. So it's a measure of the degree of elongation of the body. There are some additional predefined functions like distance to zone. If you want to work with the distance from a body point to a specific zone, so then you define which is your zone, which is the body point you want to use. Get signal is when you want to read the value from a hardware device like a leakometer. So you can use JavaScript also with hardware signals. In zone, pretty famous because you are going to use very often, for instance, for the subject counter. And the angles that you can calculate using 3 points, like in the case of the turn angle, and the moving heading. So using 2 consecutive points, you can calculate the heading angle. These are predefined, so you don't have to specify the formula. These are already, once you specify the body points, the value is returned. And then these are quite important. These are how to get the value in EthoVision back in your analysis. I think I showed almost everything. Perhaps I should have shown this JavaScript in trial control. And I think it was somewhere here. Nope, it was in the other subject counter. I quickly show it to you. I'm going to look at the procedure in the trial control in which I want to stop the trial when the number of animals in a specific zone is reached 7. So here again, I make a condition based on JavaScript. So it's not based on in zone or velocity. is based on JavaScript. Here I can specify my subject counter. So basically, this is the same text that you saw in the examples of the subject counter. And I specify here my real condition. So if the number of subjects is higher than 7, then stop the trial. And well, it works. I just tried with a trial here. And if I go to trial 2, I can see that in trial 2, for arena 1, it stopped almost immediately because you see already this a swarm of Drosophila coming by. So it stopped after a few seconds, you can see. After the number got to 7 here in zone 1, it stopped. And if I go to arena 3, you can see that it didn't stop. So the trial duration is, the track duration is independent between arenas. So it depending on when the condition becomes true in a specific arena. Okay, I think I'm done with the example that we can discuss later in the question time. And let's go to, let's see, we've done this. Yep, yeah, all done. And quickly, if you are interested in JavaScript, there's a very good course that you can follow online. First 3 hours are for free. It's made by Tony Alicea. I recommend this course for 2 reasons. Why? This is not a course for JavaScript in websites. So this is really programming stuff. And the second is that this is a very clear training. The speaker is very good in explaining, and it takes all the time to explain things like the global variables and the loops and whatever functions. So I would recommend this course. And if you want to practice with JavaScript outside EthoVision, there are some online consoles that you can use to practice with simple functions, like in this case. This is just one I encountered, but probably there are many. And finally, some credits to to one of the brains of EthoVision XT who made it possible. Egon made these JavaScript functions in his free time, and apparently it turned out that many of the questions that are asked by our customers that cannot be answered by normal variables can be answered by using JavaScript. So it became popular within the company, and it now becoming popular in outside. I hope outside among you, or those of you who are going to use EthoVision in the next few weeks or months. So yeah, I think I'm finished with the training for the webinar. Sorry, and I hope you enjoyed it. And I hope you enjoyed, and thanks a lot for watching. And perhaps see you for another training, for a webinar, maybe one about spatial analysis with heat maps in EthoVision XT. And check the Noldus website for more webinars, of course. And yeah, now I think it's question time. I leave the word to Jonathan.
Great. So there was a question for you back when you're talking about the velocity bins.
Yeah.
Roberto was asking, you had mentioned doing some filtering to smooth those results. He's asking, could you explain which type of filter should be used?
Well, yeah, you could check in the code. I don't have the code here. I go back to my experiment. And, to filter the data, so there may be options. So I'm going to show here the velocity bins. Yeah, there may be these fast transitions, you know, between 0 and 1. This is caused by the random variation of the velocity around a threshold. what you could imagine is that you, in the code, you can, I don't have the examples here, so I cannot show it to you, but you can check that the value is, if it's just above the threshold, don't change this value of the state unless it also exceeds another threshold. So it basically it's a bit like the movement state in EthoVision. So if the velocity increases, just to avoid this constant change in the state due to the oscillation of the value around a threshold, just get two thresholds. And if the value of velocity is between these two thresholds, don't change the state from the previous sample. This is what I could recommend. We don't have the code here, but we could make it maybe. And another option maybe would be just to smooth the values of velocity. If I apply, for instance, smoothing, not sure what, here I get a better representation. So here I used the smoothing value in EthoVision, and I remove part of these transitions, but not all of them. Also depending on how heavy is the smoothing, this degree of smoothing, okay? So here, for instance, you have a little hump here, and then, there's a transition in the speed. I think it much depends on the distribution of your velocity values to choose the right value of these thresholds and the smoothing factor, and how fast it changes during the trial, depending on the behavior. One thing I don't see the chat here on my, now I see it. Essentially you have two ways. Actually, we also experimented a bit with the filters inside, just like with a tail bit detector. We also have some tail bit detector filter inside the code, because for instance, I wanted to get rid of those values of the ratio that are very high just because the value of movement of the center point is very small. So if it's very small, then the ratio will become too high. So that will give me some false transition to tail beat. So in order to remove these jitters, then in my code of tail beat detector, I added one more filter. Let's see. I think you can see it here. I hope, it's not very clear, immediate, but if you see, you see this condition. The distance moved by the center of gravity, so the center point, not a tail, must be higher than 0.05. So 0.05, let's say, millimeters. And if this is true, then do the calculation. So make the ratio tail versus distance of tail versus center point. If not, if this high value of distance of the center point is very, very small, just ignore this and get back to the next sample. So it will ignore all these extractions and set the output to missing. So there are two ways to filter. One is to create a filter here, just with an if condition with a threshold, or by using the predefined filter possibilities here. I just used the smoothing just because the animal was moving around a lot. So I used the first one to smooth out the line of velocity.
Thanks for that question. Anyone else have questions for Fabrizio? If not, thanks for attending. And like Fabrizio said, look for future webinars coming up on our website.
Okay, thanks a lot. Thank you, everybody. And see you soon. Bye.